Okay, thank you for this joining this session. So, are you tired? No? Okay. Okay. So, hello everyone. So, sorry, my voice might sound a little off today. I got a small cold. Sorry about that. So today our focus is on edge device that connect edge AI with IoT system. Then, so let's get started. Yeah. Okay. Okay. So I'm Munehiro Shimomura, leading the OSPO at the Sony Semiconductor Solutions. I'm responsible for strategy and collaboration in open source. Then my colleague.
Okay. My name is Shinsuke Tashiro, and from Sony Semiconductor Solution Corporations. And now I'm working for as a system architect, a software architect of the edge device core, which we'll explain later. And then I'm working on more than 20 years of the embedded software development for Linux devices and some RTOSs. And I'm so happy and excited to be here because I'm growing up as a software engineer with Linux. Thank you.
Okay, thank you. So today I will talk about a background. Then he will explain about more details. Okay. Then first I want to explain two words. So we use the word edge device and edge AI in this presentation. Then edge device may include gateways, but here we mean end device closer to the user. For example, network camera. Then such device mainly includes sensors and small computer interface, and in some case actuators. So they can perform three main functions: sensing, processing, and actuating or outputting. So it means each device connects to the real world with the digital world. And we say edge AI. Edge AI means running AI on those edge devices. And nowadays, many chips come with AI accelerators like GPU, DSPs, and NPUs. So AI can work directly on the edge. This is already becoming normal. And as you already know, edge AI has some big benefits. First, it's real time. So data is proceed on the spot. So delay is very small. And second is save bandwidth. So no need to send all data to the cloud. So network load and costs are lower. And third, mainly privacy. So data can stay inside the device. So personal or secret data is safer. So HAI makes devices smart on the spot. At the same time, it also helps keep us trust. So in this session, we will talk about each device with edge AI, especially from the viewpoint of open source. Okay. And one more background point. I will not go into detail today, but so edge AI is now supported by many new AI technologies. Then lightweight and small footprint models like TinyML and model compression technique, vision AI, such as object detection, and new learning method like federated learning and retraining and so on, and integration with external service like generative AI, LLM, with, for example, MCP, using MCP, and powerful hardware with NPUs and AI sensor. So technologies for edge AI are rapidly evolving, and it is become easier to solve various challenges with edge AI solutions. Okay. So by the way, as you know, HAI is powerful, but there are still many challenges when building real systems. One is a diverse device environment. So each device comes in many varieties, and it's often difficult to decide which one is right for the solution you want to build. And in practice, so this usually involved a lot of try and error, trying different device and taking algorithm. Then until you find device until you find the best fit. So this is one thing. And second is resource constraints. From a cost perspective, we often have to implement solution with limited resources. And for each device, the constraint tend to be even stricter. So quite often, we can run large AI models directly. So techniques like quantization and pruning or something are needed to compress them. Then third point is complex system development and operations. So such system needs a lot of software across multiple layers, device from cloud. So and in practice, we often have to gather it and modify or adapt it and make it work together. So we need to handle some huge software components. And operation is also difficult. So each device are distributed, split like a split. So affected by the environment, hard to update, and difficult to monitor. So it's very tough. And point 4, training and inference. So first, we must choose which model is suitable for our solutions. Then data collection and training and model deployment are often separated. So to build AI models for edge devices, so data is needed. So data collected on the device is typically moved to host for training and model buildings. So it's separated. Then the resulting model is then deployed back to the edge device for testing, and this iteration must be repeated. So for future, workflow may train entirely on the edge device, but for now, this remains a tough process. And point 5 is security and reliability. We must also take security and privacy. So it's difficult to keep the security of all distributed devices at a high level. Yeah. Then now, if we look at the edge AI system from the functional point of view, so basically we always need some common basic functions. On the edge side, things like interface, sensor control, firmware updates, model deployment, and so on. So many functions needed for each device. Then other side, so host side, we need model training and management, model management, and edge device fleet management is also needed, and monitoring and data analytics. So host side needs also so many functions. And then industry-specific requirements come on top of those basics. For example, in healthcare, in healthcare industry, there are privacy standards. In automotive, also there are safety regulation and so on. So each industry has also specific basics. So the point is many of the core functions of the edge system are common across the industries. So this creates an opportunity for open source to provide a shared baseline. So this is background. Then about our software, so he will explain more details. Okay, so I'll pass to Tashiro-san.
Okay, let's go to the next page to explain more detail. Okay, first, let me explain the edge device in the ecosystem of the iTrails. iTrails is the edge AI cloud services. This is the figure in our web page, and edge device is here. So which will interact with the console. It means the cloud services and also some customer segment as extended. So, and then edge device is we defined software of the edge device as edge device software. And then we defined it as a software suite to enable functions required for edge device. And then it consists of the two components, and one is the edge device core, and the second is the edge application. Okay, so from the next page, I'll explain each two components more detail. Okay. First, before going to explain more each component, we'll explain our concept of the edge device software architecture. So we have three targets, and one is the is migration of the various user solutions. So because as Shimomura-san mentioned, so many customers want to do based on their requirement, and it varies so much. So this is the reason why I'm putting here. And then, so this means enabling easy migration of the various user solutions, as I said. So we provide a customization area called the Edge App, and then offer an Edge App SDK to deliver a great developer experience. And the second is the easy integration to the various platform. This means enabling easy porting to the various platform, and to support various sensors. Many hardware, various sensors, peripherals, and SoCs. We have prepared the edge device core, this portion. And additionally, to improve the portability, we have included a porting layer here within the edge device core. And the third one is the well-structured framework for better software quality. So this refers to structured software framework. And we have clarified the role and responsibility of each software components here, and adapted the layer structure that provides a great abstraction to a higher level component. Okay. Next. So from this page, I'll explain the key components of the edge device core. There are 6 components. And then, I don't want to go into detail, but let me explain briefly of each component. And the first one is the Edge Virtualization Platform we call EVP, and this enables the lifecycle management for on-device AI models and the edge application. So, and the second is the Sense Code, which enabling a seamless flexibility and easy accessing the processing diverse sensor data. So, and the sense code, it will be the components to communicate with the sensors and provide the great abstraction to the upper components. And we have other open source software stacks here, OneMore and WASI, which are WebAssembly, micro runtime, and WebAssembly system interface. These are the runtime of the WebAssembly, which you usually call the Wasm, and of the C implementation, and also API implementation to access to the Wasm to access to the software resources of hosts like file I/O, the network, and neural network function or something. And last two portion is the edge system manager and application. These are the as you can see here. So it will have some kind of software components to management entity of the functions, like we call the manager. So there is the set of manager, and then to provide a various function to the application. So, and on application side, provide function that edge device can complete with the services, utilizing the sense code and EVP and the managers. Okay. Okay, first, EVP. Yeah, as you can see here, we also make it open source, so you can find the URL repository here. And the feature is like this. So as I said earlier, it has the function to manage the life cycle of the AI model and the edge application. And the device authentication with services also support. And handling the communication between services. Here is the services, which will communicate with the edge device on iTunes services. And the second is the sense code. As same as you can see the URL here. And the feature is like this. So this will provide the abstraction to the upper components to manage various image sensors with unified API. It means that if some edge device has the different image sensor, edge application and these upper components can communicate with the unified API regardless of the difference in of the sensors. And also, it provides the multiplexity to the upper components. So it means that we have a image sensor having the neural network IMX500, and it has the many features, not only the image sensor, but also neural network engine. And sense code will provide the API to access to these two features as well. So and in a single device, it will provide the multiple access multiplexity. So this is one of the big features of the sense code. The third one is one more and WASI. It is the from the Bytecode Alliance, but we already contributed some big features like WASI-NN, neural network access, and also socket thread support. And it is already available in upstream. And one more feature was the feature. It is not open source, but it is. I'll explain the basic feature here. We compiled with the Wasm, and also with AOT ahead of time compiler, near native speed with available, and also small footprint, and supporting the many OSs and architecture. And as for WASI, it will provide a standard API defined in the WebAssembly specification, and it will guarantee the same API functions on the different platform. Okay, the next one is the edge system application managers. Here's the repo, URL repo, and the feature is like this. So these components is different from these components. It will provide some basic system features to the other components, like getting NTP time, because time synchronization is important. And also store parameters to connect to the services, or firmware deployment, AI model and the firmware deployment is also supported, and anything like that. Okay. And last, this AI model. So we already, as you can see here, so through the WASM interface, edge application can communicate with the AI model inside the host site. And so EDC have the function to load the AI model in a specific directory in the file system, and can be accessible from the edge application through the WASM. And as for IMX500, it has the feature to do some AI inference on device. And then we already have a open source model here. So it is open, and everyone can access and get the model. And also, this is a paid application, but we also provide this the tool to create and customize the AI model. We named Brain Builder for A12. Okay, from this slide, I explained the different part of the edge device software. We named edge application. Yeah, as I explained earlier, so because EDC support the WebAssembly and WASI, so application also support the WebAssembly. And also high-level languages are supported, like C and C++. And Python, we are discussing about this. So, but we would like to support more and more languages. And extensibility by WASI is achieved, as explained earlier. And also, as for Wasm, we support the sandbox for application for security. It means that edge application is loaded. Some limited area can be accessible from the device edge application. So other address of the host site cannot be accessed from the edge application. And runtime deployment is supported. It means that we can replace the application when host is running. Okay. Okay, and we have explained that many open sources from our company, but from this on this slide, I explained the coverage of the OSS to provide the edge AI solution development. So we have these three open sources, which can be used to develop the AI application. And all components are available as open source. Okay, the one is the Edge App SDK, as I explained earlier, and it is designed for who wants to make it easy to create the application for edge device. And then these are the feature set. So support high-level languages and unified user-friendly APIs. We have also the good sample application. So you can start with the sample device and customize it. You can create the application so easily. And also we have some reusable components in the SDK. And the last one is we have a command line tool to deploy the Edge AI app and the Edge AI model and the control app by remote. So you can do any development on the command line. And second is Edge Device Core, as I explained earlier. So this is for who aim to develop the edge device interacting with the management services. And so as you can see on the table, so you can bring up the edge device with the Raspberry Pi and the AI camera having the MX100 as a POC. It should be quite easily. And of course, and since this is OSS, you can do porting EDC to the other devices for production, like a camera vendor. If a camera vendor wants to create some camera which is the A12 edge devices, each device, EDC can be used for and can port to their platform. The last one is the local console. Actually, it is already introduced on previously, but it can also be used for this solution. So this is this is for who wants to simplify the management and the visualization of the various edge devices and the edge application. So it's like management works as a management entity. And the feature set is like this. So expansion of the management edge devices and the extension of the application and runtimes. And the enhancement visualization method is supported here. And the collaboration with the other system is also in scope. Okay, from now I'll explain I will do some live demo on here. And this is the structure of the demo. So yeah, as you can see in small setups in here. So yeah, there is a Raspberry Pi 5 and the AI camera is inside, and it will communicate connected to the Linux, which is running on the VirtualBox of this PC, and there is a IP level connection here. And then from on this side, EDC edge device core and the edge application is already installed, and there is a two IR model is loaded license. So yeah, as you may see our booth, yeah, we made some this kind of the license plate detection demonstration, and I will demonstrate and how to bring up how to customize. And so here you can find the license plate detection model in the MX100, and it will detect the this is very small figure, but yeah, it will detect the license plate and put the rectangular. And then edge application will do the another inference to recognize the license plate. And the AI model is used as through the Wasm, and it will the edge application can get the metadata from the detected license plate, and then it will send these two data through the through this network, and then this side can receive the data, and from this side, yeah, there is a demonstration application running, and it will show the image and also metadata like this. And also, there is on this side, HBAC CLI is running, and also HBAC SDK is also installed, and we can customize on this side. Okay, and by using this CLI command line tools, yeah, we can deploy the AI model and then edge up and the configuration or something. Okay, from now I'll show you how to do that. Okay. Okay, as you can see here, yeah, it's very, very small character, so it's hard to recognize. But yeah, I'm already logged into the Raspberry Pi as via SSH, and okay, and now, and if just a second. Already, the edge device core and some other components, required components, already installed to the Raspberry Pi. And then, yeah, the edge device core can run as a system services, so we can start. So just a second. It's hard to see that like this. So, yeah, let's see the status. So, yeah, it is already running. So. But just in case, just stop and start again. Yeah, this is a very common way to start and stop these services. So yeah, you can be so familiar with this. Okay, already started. And see the, oh, sorry. And you can see the logs like this. So yeah, this is because this is running as a systemd services. So yeah, it is already running, so I will do the command line, start the command line application. Okay, so let's start the edge up CLI from here. Okay, looks like connected. And now no air model and edge up is loaded, so so first, let's deploy the AI model. Completed. And the second, let's deploy the edge up. Okay. Yeah, I'm deploying the Wasm edge up now. completed. Okay, and as you can see, the two AI model and the app is already loaded. Then we can start. Then we can start to execute this command. And let me explain a little bit about this command means. And as you can see here, we will send the configuration, and inside the configuration, we will change the PS. It stands for processing state to 2. And the 2 means it running. Okay, so I will show you the content of the configuration file. Just a second. Just a second. Okay, now I'm opening the directory of the Edge App SDK, and now I am logged by SSH. And then, this is the configuration file, which will be sent with this command. And here you can see, we set this application to send the metadata and input data, I mean the image, to the demo HTTP server. This is URL and the port of the demo application. And okay. Okay, let's go back and start inference. Yeah, it already started. Okay, now I will start the demo application. Something is sent to the web server now. So demo service is already started, so okay. Okay, now nothing is detected, so you can see this wall, but you put this. Oh, yeah, you can see that the device detected and like this. And okay, so you can see that how it works. Oh, thank you so much. Yeah, I love think it's working. Okay, go back. And if you want to customize the application, I will show you how to do that. And let's stop the. Okay. And with this command, PS1 means that the processing state would stop, so the inference is stopped. And then. And for example, if we want to customize the rectangle of the on the image, if we want to change something, so I'll explain the example. So this is the function to which is called on every image on every inference. And here you can see that it defines the color of the rectangle. And if we want to change from the red to the blue, save it and build. Oh, sorry. Need a bit more time to complete it, but it should be done quickly. Okay, completed. And as you can see, as you can see in the timestamp, it is built just soon before. Sorry that this is the Japanese time. Okay, and then so after build, go back to this, and you can deploy the application again. Completed, and do the same thing again. and start the service again. Okay, start it again. Then, okay. Oh, it's hard to see. Yeah, as you can see, the rectangular color is changed. So, yeah, this is the live demonstration. Thank you. Okay, so let's go back to the presentation. Oh. Okay, and on this page, I'll explain the edge-based software feature enhancement. Yeah, as I explained, so we are targeting the more and more platforms. So, yeah, support many OS like Yocto Linux is the first scope, and secondly, we would like to focus on some real-time OSs, NetWorks, FreeRTOS, and Zephyr or something. And also want to support some other SoCs, not only the Raspberry Pi, but also some the platforms of the SoC vendors. And support more feature is also in scope. For example, Raspberry Pi there is no need to do some OTA from the services, but if someone wants to port the ADC to the other platforms, system OTA should be required because, due to the security reason or something. So system OTA is also in scope, and also streaming is also because this is actually this is camera, and the camera feature is also required for other cameras. So streaming is also in scope, and also support multiple sensors are also in plan. So now ADC supports IMAX fan rate and AI model. The AI camera only, but if some new sensors will be in the market, we should support other sensors. Okay, this is the last page. So this is for call for action. So we already have an open source repository here, so please check and give some any feedbacks. And community will be ready soon. So we will do announcements. So please join us. And we are welcome of the contribution of the many members. And if you have some comment or some input, please contact to this URL. We will have OSPO the forms to input some news, input some comments. Okay, that's all. Thank you. Almost no time. Okay, any question will be welcome after that directly to us. Thank you so much.